Sơn Tiên Phong dịch. Ngày nay, trí tuệ nhân tạo đang giúp đỡ các bác sĩ trong việc chẩn đoán bệnh cho bệnh nhân, giúp các phi công thực hiện các chuyến bay thương mại và giúp các nhà quy hoạch thành phố dự đoán giao thông.
But no matter what these AIs are doing, the computer scientists who design them likely don't know exactly how they're doing it. This is because artificial intelligence is often self-taught, working off a simple set of instructions to create a unique array of rules and strategies. So how exactly does a machine learn? There are many different ways to build self-teaching programs, but they all rely on the three basic types of machine learning: unsupervised learning, supervised learning, and reinforcement learning. To see these in action, let's imagine researchers are trying to pull information from a set of medical data containing thousands of patient profiles. First up, unsupervised learning. This approach would be ideal for analyzing all the profiles to find general similarities and useful patterns. Maybe certain patients have similar disease presentations, or perhaps a treatment produces specific sets of side effects. This broad pattern-seeking approach can be used to identify similarities between patient profiles and find emerging patterns, all without human guidance. But let's imagine doctors are looking for something more specific. These physicians want to create an algorithm for diagnosing a particular condition. They begin by collecting two sets of data: medical images and test results from both healthy patients and those diagnosed with the condition. Then, they input this data into a program designed to identify features shared by the sick patients, but not the healthy patients. Based on how frequently it sees certain features, the program will assign values to those features' diagnostic significance, generating an algorithm for diagnosing future patients. However, unlike unsupervised learning, doctors and computer scientists have an active role in what happens next. Doctors will make the final diagnosis and check the accuracy of the algorithm's prediction. Then computer scientists can use the updated datasets to adjust the program's parameters and improve its accuracy. This hands-on approach is called supervised learning. Now let's say these doctors want to design another algorithm to recommend treatment plans. Since these plans will be implemented in stages, and they may change depending on each individual's response to treatment, the doctors decide to use reinforcement learning. This program uses an iterative approach to gather feedback about which medications, dosages, and treatments are most effective. Then it compares that data against each patient's profile to create their unique optimal treatment plan. As the treatments progress and the program receives more feedback, it can constantly update the plan for each patient. None of these three techniques are inherently smarter than any other. While some require more or less human intervention, they all have their own strengths and weaknesses, which make them best suited for certain tasks. However, by using them together, researchers can build complex AI systems where individual programs can supervise and teach each other. For example, when our unsupervised learning program finds groups of patients that are similar, it could send that data to a connected supervised learning program. That program could then incorporate this information into its predictions. Or perhaps dozens of reinforcement learning programs might simulate potential patient outcomes to collect feedback about different treatment plans. There are numerous ways to create these machine learning systems, and perhaps the most promising models are those that mimic the relationship between neurons in the brain. These artificial neural networks can use millions of connections to tackle difficult tasks like image recognition, speech recognition, and even language translation. However, the more self-directed these models become, the harder it is for computer scientists to determine how these self-taught algorithms arrive at their solution. Researchers are already looking at ways to make machine learning more transparent. But as AI becomes more involved in our everyday lives, these enigmatic decisions have increasingly large impacts on our work, health, and safety. So as machines continue learning to investigate, negotiate, and communicate, we must also consider how to teach them to teach each other to operate ethically.
Today's computers can pilot spacecraft and perform surgery. But according to computer scientist Alan Turing, the real test of a computer's intelligence is basic small talk. Check out this video to find out why.